Hello everybody, we are going to talk about properties of addition and multiplication today. Commutative property is our first property we need to know about. So think about the root word. What comes out of commutative? The word commute. So commute means to go back and forth from a location. So you're going to move places. That's kind of my code word to help me remember. So commutative property is the one where you are moving places. You're going from one location to the other. So in addition, what does that look like? Well, A plus B is the same as B plus A, right? If I do 6 plus negative 1, that is the same as negative 1 plus 6. And this property can work with multiple numbers. I'm just giving you an example where there's only 2 numbers at this moment. Same thing works with multiplication. If I have A times B, they can commute or move places, and A times B is the same as B times A. So if we tried it with numbers, if I tried 8 times 5, this is the same as 5 times 8. Excellent. The associative property. The associative property is who you associate with, who you hang out with. Yeah, I associate with those guys. They're totally cool. Oh, no way I don't associate with her because she's like totally as if like uber grody. So the associative property is who you hang out with. Who you hang out with. X plus Y plus Z. The difference is, in this first one, like X and Y are totally best friends, and like Z is like not even hanging out with him because he doesn't associate. But like then they change the order, or they don't change the order at all. But the only thing that changes is like the association, like who's hanging out. Now X is a total loser, and Y and Z are totally BFFs. You know what I mean? So exactly the same order, but the associations, who they hang out with, change. Let's try it with a number. If I had 5 plus 7 plus 3, if I keep this in the same exact order, 5 plus, and then just change the grouping to 7 plus 3, the answer is exactly the same. I could add this first and get 12 plus 3 is 15, but a lot of times we like to make groups of 10 first, so 7 and 3 is 10, and then add 5 second. Same answer, we still get 15. Multiplication, same idea. So again, order X, Y, Z, X, Y, Z. They stay in the same order. The only thing that changes is who they hang out with, the association. So if we were to try this with, I don't know, let's do 3 times 2 times 5, and I wanted to change the grouping, I'm going to keep the same order, 3 times 2 times 5. Again, I changed the order, the grouping for the same reason, because 3 times 2 is 6 and 6 times 5 is 30, right? But I and my brain work a little bit better if I do 2 times 5 first, which is 10, and then times 3, and I still get 30. Okay? So, associative property is changing who you hang with. Identity property. You know, those things pretty tough. You're really trying to keep your identity, and you want to be very individual, and so you want to stay who you are. So, in addition, if I am a N, and I want to stay an N, N's rule, and I need to add something to it, but I have to stay an N because I want to keep my identity. Keep my identity. Okay? What can I add to N so that I stay an N? Yep, you are correct, a 0. Try it with a number. I always wanted to be a -3/4. So what can be added to me so that I still am a negative 3/4? Well, you can add a 0, because any number plus 0 ends up staying that number. That is your identity property of addition. What about multiplication? Same idea, I want to keep my identity. Let's say I am a n again, because I'm a Nakamu, and I want to multiply it by something so that it stays and keeps my identity as an n. N times what equals n? You're correct, 1. Secret agent number 1. So if I tried this with a number, I want to be a 7. What can I multiply myself by so that I stay a 7? You are correct, a 1. Secret agent number 1. That is the identity property, keeping my identity. Inverse property. You know when you're solving an equation, 1 or 2 step equations, and you want to get the variable by itself? Well, if I had, for instance, x plus 5 equals, I don't care, 12, okay? And I want to do the inverse operation to get the x, or to get the x by itself, I would want to do the inverse of plus 5, which would be minus 5. Or you can think of it as adding the opposite of 5. So what's the inverse of plus 5? It would be minus 5. Or adding a negative 5. So that's what we do here in the inverse property. A plus its inverse, or its opposite, negative a, add up to 0. If I tried it with a number, it's like saying 5 plus negative 5, add up to 0. Multiplication property, the inverse property of multiplication. Similar idea, but let's say you have 3x equals 12, and I want to get the x by itself, so I want to get rid of the 3. Well, we could divide by 3, but it's a multiplication property, so I could also multiply both sides of this inequality by the reciprocal, and that would also solve this equation. So what is the inverse of 3 multiplied by 1/3? So if I take a and I multiply it by its reciprocal, 1/8, 1 over a, I get 1. So if I was to try that with a number, if I was to take 3, I would multiply it by 1/3. That would be the inverse property, so that it kind of, you get rid of it, and you would end up with a 1. This one property is a little bit weirder because the inverse property for addition is ending up with a 0, and the inverse property for multiplication is 1. Well, why? Because if you add 0, you keep the number. And if you multiply by 1, you keep the number. And that's really the reason why. Property of 0. For addition, it is just the same as the inverse property. So if you have x and you add its opposite, you get 0. And for multiplication, it's what, if you have a number and you multiply it by 0, you will end up also with 0. So I think of the property of 0 as you want the solution to be 0, so figure out how to get to it.